All right, welcome to the last e-learning session, at least for now, but we will be starting up again once spring break is over because we are still going to be e-learning until at least April 17th here. So if no questions come in, I'm just going to be doing random math stuff, but feel free to interrupt if you so desire. Yay! But starting off, probably with probably going to do some more standard form stuff because people have a hard time finding vertices. That's the actual word, vertices. People have a hard time finding vertices because, I don't know, it's hard to plug numbers in. I don't know. But if we just make one up, let's say f of x equals, let's do 3x squared minus 4x plus 1. Just having that alone, you can figure out what your y-intercept is just by looking at it, because your y-intercept when it's in standard form will always just be your constant. Couple other things that you can notice is at 1. And then with this, because the 3 is positive, you can also tell that this is going to open up. And from there, you're going to go ahead and find your axis of symmetry. So remember that axis is always going to be x equals negative b over 2a. That comes from the quadratic formula itself. It's just without the discriminant. But in this, at least with this example, our a would be positive 3, our b would be negative 4, and our c would be positive 1. And so when we plug in negative 4 would be positive 4. And so we'd have positive 4 over 2 times 3 would be 6. And so then you would simplify that fraction. You can divide by 2 on the top and bottom, so that'd be 2 over 3. And so then you would have to plug this in to the formula itself. So for all those x's there and there and there. And because it's an ugly fraction, I'm probably not going to plug it in all the way because I just made this up off the top of my head. Now to make this work a little bit nicer, here's what we can do. This is some math magic for you right here. If we change that 4 to a 6, we'll make this work out nicely. But if we change that negative 4 to a negative 6, there we go, then we would end up with a positive 6 over 6, which would be 1. And so then our axis of symmetry would be at x equals 1. And so then to find our vertex, we would just plug that in. And so we would have f of 1. Remember function notation, that's just like y, and the number inside is just telling you what we're plugging in. But that would be 3 times 1 squared minus 6 times 1 plus 1. And so then when you're simplifying that, 1 squared would be 1 times 3 is 3. Negative 6 times 1 is negative 6. And then you add the 1 in. And so then 3 minus 6 is negative 3. And then when you add the 1 in, that would give you negative 2. And so then your vertex would be at 1, negative 2. Looks like a U. vertex. And you can also tell because it opens up that this vertex would be a minimum, because when you think about it, if it's opening up, then that means your vertex would be at the bottom. If a graph was opening down, like down there, then that would be a maximum. Okay. What else? What other randomness can we do? We can make up more of these. And here's the thing with quadratics, there's so much to them that it's kind of crazy. In the last units, we did like quadratic formula and stuff so that we could find the solutions to these things. And remember, when you're graphing these, the solutions are just your x-intercepts. So it's wherever the graph itself is touching the x-axis. So let's see. We'll do another f of x because function notation. Again, people mess it up for some reason. You just gotta understand that math is sometimes a different language. But let's say that we had something like negative 2x squared minus 4. Here we go. Notice that in this case, my a would be negative 2, and b is normally the number that's in front of the x, but I have no x, which means my b would be 0, and then my c would be negative 4. Now, the nice thing about this is that when you go to do your axis of symmetry, all you're plugging in is 0 for that negative b, because negative 0 is still 0, and then 2 times negative 2, it doesn't matter though, because your numerator is 0. Anytime your numerator is 0, you know that it's just going to be x equals 0 for your axis of symmetry. Boop. And so then that makes your life really easy, because then to find your vertex, you just take that 0 and plug it in. And the greatest thing about this is that when you plug in 0 for x, you just get your y-intercept. And so this would be negative 4. Okay. If I wanted to find the zeros for this, technically, this is one that I could solve by square roots, because I can plug in 0 for x, because again, or not 0 for x, 0 for y, because again, with x-intercepts, you're looking for when you're hitting the y-axis. And so if I do that, I would say 0 equals, negative 2x squared minus 4. And then we're just solving. So since it's minus 4, we would add 4. Boop. And so then 4 is negative 2x squared. And so when you divide by the negative 2, you get that x squared is equal to negative 2. And here's the thing, when you take the square root, you guys, at least if you're in Algebra 1, do not know what to do with negative 2 yet, because that comes into Algebra 2. And so when you get that negative number, you know that there's no solutions, which tells you, based on this, that you could actually sketch a little graph if you wanted to, because our vertex is at 0, negative 4. So 1, 2, 3, 4. It's down there. My axis of symmetry is this graph, which actually, you know what? We're going to scoot this up. Did not think that all the way through. There we go. But since my y-intercept is negative 4, and since this one is going to open down because of that negative, then that means that my vertex is a maximum, and that means that this parabola comes like that. And so it never will hit the x-axis, and so that's why if you try and solve it, you get no solutions. What else can we go over that would be helpful for Algebra 1? You can also remembering your increasing and decreasing, which now that I've scrolled down, remember that when a function is increasing or decreasing, you're just looking at its slope. And so with this one, this function would be increasing from this left side, and depending on the notation that you need, you would say that it is increasing from negative infinity, and this is interval notation, but you would have negative infinity and negative 4, like that, or not negative 4, to 0. because you're looking at your y or your x values. And so this graph would go forever to the left, which would be negative infinity, and then it stops at 0 before it starts to decrease on the left side because that graph's going down. And so this graph would be decreasing from 0 to positive infinity because it would just keep going forever and ever. Other, let's see, domain and range for these, we haven't really gotten into yet in class, but domain is always your x values. So usually with domain at the Algebra 1 level, we just say all real numbers or whatever it may be. But you can also say that your x values are between infinity and negative infinity, and to do that with inequalities, you just write it like that. You're saying that x lies somewhere between negative infinity and infinity. And I know if you're just starting out in math, that notation just looks kind of strange and looks like a different language. It's because in a way it kind of is. But if you get used to the notation, it makes it much easier to read later on. Now remember, your range is your y values, and so for your y values, you're looking at when are my y values true. In the case of this graph, this would keep going forever and ever and ever down, which means my y values could go all the way to negative infinity. But then when my y value gets to -4, that's where the vertex is, that's where my range stops. And so because it's y's, you can think about it, y is greater than or less than -4. And in this case, because it's going down, this would be that y is less than or equal to -4, because it actually does have a point at -4, even though it doesn't go past it. It does include -4 itself. What else? So many options. We can go ahead and do this with another one, but if new questions come in, then I will probably just sign off because food, can't even lie. Food is the best thing ever. Can I just say? I'm definitely one of those quarantine. I ate all of my snacks the first 2 days. Guilty as charged, but it's fine. Erasing all of this. All right, so if we do one more, boop, let's say 2x squared minus 4x, and we'll do -1. Why not? So from this, we can find our axis of symmetry because x is -b/2a, which I'm sure some of you would probably be sick of hearing me say that at this point. But negative b would be -4 and 2 times 2. And so that would leave me with +4 up top and +4 in the denominator, which tells me that my axis of symmetry is at x equals 1. Okay, and that makes our life real nice because when we go to plug that in, we would say f of 1 equals 2 times 1 squared minus 4 times 1 minus 1. And so then 1 squared is 1 times 2 would give you 2. -4 times 1 would give you -4, and then -1. 2 minus 4 is -2, minus 1 is -5. So our vertex would be at 1, -5. And so oops, that was a bad line. Boop, boop. And this is going to be a quick sketch, but our axis is symmetry at x equals 1. Boop, 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 boop. And then our vertex is at 1, -5. So that would go right there. And then to get your other points, first off, you can get your y-intercept because remember your y-intercept is just your constant. And so since that's -1, that tells me that that is going to hit right here. And that point is 1 away from my axis of symmetry, so I can go 1 away on the other side. And so then all I really need to do is plug in f of, let's say 1, 2, 3, so that I can get the next point over. So if I plug in 3 real quick, that would give me 2 times 3 squared minus 4 times 3 minus 1. And so 3 squared is 9, and that would be 2 times 9 minus 12 minus 1. 2 times 9 is 18, and minus 12 minus 1. That would give me 6 minus 1, which is 5. And so at 3, I'd be up at positive 5. Oop. Which means at negative 1, I would also be up at positive 5 because this is a parabola. And then you try and curve it as best as you can, like so. And this graph would be increasing from 1 to infinity and would be decreasing from negative infinity to 1. Okay, I have not had any questions pop in yet, so I'm going to go ahead and sign off so that I can eat. But you all have a lovely quarantine. We will see you back here on March 30th when we do more live streaming, both on Schoology and in YouTube. So we will see you all later.